Okay, so today we're going to be going over 6.5, the addition rule for OR. Okay, so our learning target, I can calculate OR probabilities involving multiple criteria using addition, whether mutually exclusive or not. So let's talk about OR for just a second. In an OR probability, you can meet the criteria for A and not meet the criteria for B. Or you can meet the criteria for B and not meet the criteria for A. Or you can actually meet the criteria for A and B. Okay? So as long as you meet one of these three, then you could be in an OR probability. Okay? So that's just a good thing to keep in mind. It might sound a little confusing right now, but hopefully it makes a little more sense as we keep going. Before we jump into an example, let's also talk about mutually exclusive events. Okay, two events are mutually exclusive if the criteria for A has nothing to do with the criteria for B. There's no intersection here. You can also have two non-mutually exclusive events where there is an overlap right here, this intersection, okay? Where sometimes you can be in both A and B's criteria. That would be like this bottom one down here. Okay, so when we're doing OR probabilities, if we have a mutually exclusive event, we're going to take the probability of A and add that to the probability of B. Okay, that's all we're going to do. If they're not mutually exclusive, then we're still going to add those two probabilities together, but we're actually going to do another step here and subtract what they have in common, or this intersection right here, okay? So let's take a look at an example, see if we can make sense of these, okay? Example 1 says 100 students were surveyed about their preference between dogs and cats. The following two-way table displays data for the sample of students who responded to the survey. Okay, so here we've got our table, those who prefer dogs, those who prefer cats, those who have no preference, and that's divided into males and females, and then of course we have our totals on the bottom and on the sides, and our sample size of 100, okay? So part A says find the probability that a randomly selected student prefers dogs. Well, this is straight from 6.4, we're just finding a probability. So I'm going to look up here at my table. I'm going to say, okay, prefers dogs. How many total do I have prefer dogs? I've got 56. So that right there is going to be my top number for my probability, 56. I'm going to put that over my sample size, or my total number of 100, the 100 students that were asked. Okay, so my probability is 56 over 100, or if we reduce that, 14 over 25. Okay. Now problem B says, are the events prefer dogs and prefer cats mutually exclusive? Well, the easiest way to do this is to look at my table and see if there's any intersection between the two events it's asking for. So it's asking for prefer dogs and prefer cats, right? So I'm going to look up here at prefer dogs, and I'm going to look straight across, and I'm going to see, does it intersect with prefer cats? Nope, it intersects with males and it intersects with females, but it never intersects with prefer cats. Same with prefer cats, there's no intersection there. So we can say because there's no intersection, they have nothing to do with each other, so yes, they are mutually exclusive, okay? Then in part C, it says find the probability that a randomly select student prefers dogs or prefers cats, okay? So I'm just going to set this up with two probabilities. My first one, I'm going to do prefer dogs, and my second one, prefer cats, okay? So let's just look at the dogs. Well, I've already said that I've got 56 people out of 100 that prefer dogs, okay? And if I look back at my probability up here, I'm just adding them together, right? Just adding those two together because we're mutually exclusive. Okay, so I'm going to add this to my probability of those who prefer cats. Okay, how many prefer cats? If I look up at my table, preferred cats, 36 of them prefer cats. All right, so I'm going to add that to 36 out of 100. Okay, and if you add those across, you get 92 out of 100 prefer dogs or prefer cats. And that simplifies down to 23 over 25. Okay? And then we're done. Okay? So now let's look at question D. Are the events prefer dogs and female mutually exclusive? Okay, I'm going to look up at my table here. Prefer dogs. I'm going to see if it intersects with female anywhere. No, right there. Boom. Prefer dogs and a female intersect right here. Because there's an intersection there, I can say no, they are not mutually exclusive. Okay, so when they intersect like this, prefer dogs and females, this 20 right here basically represents this middle part right here. Okay, so now E is asking to find the probability that a student prefers dogs or is female. So what we just said was not mutually exclusive. We got to find the probability for. Okay, so I've got preferred dogs. I'm going to say that one's my blue. And is female is going to be my red. Okay, well, what's the probability I prefer dogs? Okay, well, I've already said that a couple times now. That's 56 out of 100. Okay, and I'm still, if we look at our formula, I still add them together. So I start the exact same way. So I'm going to add that to my probability of being a female. What is the probability of being a female? I look at female. Well, I've got 52 total females out of 100. 52 over 100. Okay. Now, because I said these were not mutually exclusive, I have to take care of this extra step here, right? I've got to subtract what they have in common. Well, what do they have in common? What they intersect, right? So where do they intersect? Prefers dogs, females, that 20, right? We're talking about that 20. Okay, so this is my intersection, this 20. So I'm going to come down here and I'm going to subtract that 20 away because that's what my formula says. So subtract what they share. Okay, and now I've done all three probabilities that it asked for, the P of A, P of B, and P of A and B, like my equation says right here. Okay, so I'm just going to add straight across. 56 plus 52 minus 20. Well, that's going to give me 88 over 100. Okay, and that simplifies down to 22 over 25. And that's it. I'm done. So if you pay attention, it looks very similar, these two probabilities. I just do the same thing, but if they are not mutually exclusive, I'm subtracting that extra probability here, okay? That's all this is. Okay, so let's take a look at another example here. Okay, so what is... This one says there is 60 students in the music department at a local college. Of the 60 students, 40 play an instrument, 30 sing, and 20 play an instrument and sing. Let I be the event that a randomly selected student plays an instrument. Let S be the event that a randomly selected student sings. Okay, so what is the probability that a student plays an instrument? Okay, so I'm looking for those who play an instrument. Well, in my story problem, it says right here, 40 of them play an instrument. Okay, that one's pretty easy. So I'm going to put 40 over my total sample size. My total is 60. I've got 60 students. So 40 over 60. Or we can simplify that down to 2/3. Okay, 2/3 of my student play an instrument. Okay, now what is the probability that a student sings? Okay, so now I'm looking for all the students who sing. Well, it says 30 students sing. So I'll say 30 over my total. My total is 60 again. So 30 over 60. In other words, 1/2. Or if you like percentages, you could say 50% as well. Okay, so 1/2 of them sing, or 50% of them sing. Okay, now this one's got a weird symbol in it, right? Okay, it says, what is the probability, and this is read, of I intersect S? So what does that mean? Well, it also says in words, the probability that a student sings an instrument, plays an instrument, and sings. Okay? So, in other words, this upside down U is called an intersection, and it means and. Okay? It means and. So what's the probability that a student plays an instrument and sings? Well, that's also told up here. It says 20 play an instrument and sing. Okay? So I've got 20 out of my 60 students who play an instrument and sing. Or in other words, 1/3 of them. Okay. So now this bottom one, what is the probability of I union S? Okay, so another weird symbol here, that union. Okay, so the probability that a student plays an instrument or sings. Okay, so this U-looking one, it's called a union, means or. Okay, and that's just a couple notation things that could come in handy later. All right, so I'm going to do this exactly like I did. I always have an addition. So the probability that a student plays an instrument. Okay, well, I know 40 out of 60 of them play an instrument because I found that earlier. Okay, now I need the probability that a student sings. Well, I also found that one. I know that I can add this to 30 of them sing. Okay? And now I need to decide, are they mutually exclusive or not? Okay? One way to find out if they're mutually exclusive is my total, or 60 in this case, should equal all my other numbers combined. So it should equal my 40 plus my 30 plus my 20. Okay? Well, in this case, we end up with 60 is equal to not 60 here. Okay? This is actually 90. Okay? So it didn't work out that those are equal. Or in other words, these are not mutually exclusive. If it ends up that they are equal, then they will be mutually exclusive, and we have no problem. We don't have to do the subtraction. But these are not mutually exclusive. They have some overlap in them. Okay? So I can come up here and I can say, well, what's the overlap? How many play an instrument and sing? Well, I already figured that out, right? In part C. I know that 20 out of my 60 do both. So if I subtract that overlap, then I will end up with 50 over 60, right? Okay, so that also simplifies down to 5/6, and that's our answer. Okay, looking at number 3. It says Johnny rolls a fair 6-sided die and a fair 4-sided die simultaneously. The sample space of all possible outcomes is shown below. Okay. Well, the first thing I want to know is, what is my sample size? So I can count up all these boxes. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so I've got 24 possible outcomes. So that's going to come in handy when I'm making probabilities, because we need probability, or the sample size, when making probability, right? That's the bottom number in our fraction. Okay, so let's read number A, or letter A. It says, let A be the event that the 6-sided die is 2. So I'm going to underline that one blue. Okay, so let's just look at that. A is the event that the 6-sided die is 2. Okay, well, in all these boxes here, I've got 2 dies. I've got a 6-sided die and a 4-sided die. Okay, the 6-sided and the 4-sided. So I'm looking for all of the places where the 6-sided, or the square is 2. So this one right here is 2, so I'm going to put an A right here. Okay, and luckily for me, they actually organized this in a way that all the places where the 6-sided die is 2 is down this column right here. Okay, now let's look at event B. It says let event B be the event that the sum of the dice is 7 or more. Okay, so what does that mean? The sum of the dice is 7 or more. So what that means is I'm going to add up my die. So this 6-sided die is 1, and this 4-sided die is also 1. So if I add those together, I get 2. Okay, this 6-sided die is 2, and this 4-sided die is 1. So that gives me 3. This is 3 plus my 1. That gives me 4. This is a 4 plus my 1. That gives me 5. This is a 5 plus my 1. That gives me 6. And 6 plus my 1 gives me 7. So what I'm going to do is I'm going to come across here and I'm going to add all my die together. So this is a 1 and my 4-sided is a 2. So that's going to give me a 3. This is going to give me a 4, a 5, a 6, a 7, and an 8. So give me a 4, a 5, a 6, a 7, an 8, and a 9. This will give me a 5, 6, 7, 8, 9, and a 10. Okay, so now I've got all the sum of my dice. Okay, I've added them all up. And it says any number that is 7 or higher gets a B. Okay, well, this right here is a 7. So this is going to get a B. Okay, now looking at my next row, this isn't a 7. Nope, nope, nope. This is a 7, so this gets a B. And this is higher than a 7, so this also gets a B. Okay, and anywhere it's a 7 or higher, I'm going to put my B. Just like that. Okay. So I'm going to erase all these black numbers here so it's a little easier to see for us. But now I have all my A's and all my B's set out, okay? It wants to know what's the probability of A or B, okay? Well, I'm going to set up my 2 probabilities. Well, how many A's do I have? I have 1, 2, 3, 4. I have 4 A's. And how many total do I have? Well, we already counted. We have 24 total. So 4 over 24. I'm going to add that to the probability of B. How many B's do I have? Well, if I count all those up, I get 10 of them. 10 of my 24 are B's. Okay, now I need to see, is there any overlap? Or in other words, is there any square that has both an A and a B? And the answer is no. There's no overlap. These 2 events are mutually exclusive, so I don't have to subtract anything. Okay, so I can just add my 2 fractions together. I get 14 out of 24, or 7 out of 12. Okay, and that's it. For part A, that's all we have to do. We found the probability. Okay, now for part B, it says let A be the event that a 4-sided die is 3. Okay, so our event A has changed. Last time, the 6-sided die had to be a 2. Now my 4-sided die, or this triangle-looking one, has to be a 3. So where is the triangle or the 4-sided die of 3? It's all of these ones, right? All of these give me a 3. So in all of these, I'm going to put an A there. Okay, because all of these meet the criteria for A. And now it says let B be the event that the sum of the dice is 7 or more, right? Okay, so that one actually didn't change. So I don't have to erase my B's and move them around. That's going to be the exact same. Okay, now that I've got my A's and B's on my picture, I'm just going to set up my probabilities. Okay, how many A's do I have? Well, if I count them up, I have 6 out of 24 have an A. Okay, I'm going to add that to how many B's I have. I've got 10 out of 24 have a B. Okay, now I need to see, are these events mutually exclusive, or does any box have both an A and a B? I look up here and yes, this box has an A and a B, this box has an A and a B, and this box has an A and a B, right? Okay, so I'm going to come down here and I'm going to subtract what they have in common. They have 3 out of the 24 that they share. So 10 plus 6 minus 3 gives us 13 out of 24. And that's it. So that one had that extra step because we shared a couple of boxes. Okay. Example 4 says a standard deck of 52 cards contains 4 suits. It's the hearts, the clubs, the diamonds, and the spades. Each suit consists of cards numbered 2 through 10, a jack, a queen, a king, and an ace. Okay, so it's just a standard deck of cards if you've ever played a card game like War. Okay, so it says Anthony decides to pick up 1 card at random from a standard deck of 52 cards. Let T be the event that he chooses a 3. Okay, so I'm going to make that one blue. And let D be the event that he chooses a diamond. Okay, so what is the probability that he chooses a 3 or a diamond? Okay, so let's take this one at a time. Let's look at the blue, or the event that he chooses a 3. Well, if you've ever played with a deck of cards, you know that there's 4 of every card, okay? So I've got 4 3s out of my 52 cards, okay? Now I need to look at the event for B. What is the event? He chooses a diamonds. Well, how many diamonds are there? Okay, well, there's 52 cards and there's 4 suits. So if I do 52 divided by 4, that'll tell me how many is in each of these suits. Well, 52 divided by 4 is 13. Okay, so I have 13 out of my 52 cards that are diamonds. Now I need to think, are there any intersection between these cards? Is there a card that is a 3 and a diamond? And the answer is yes, it is the 3 of diamonds, right? So I need to subtract that 1 card out of my 52 cards because they share that card. Okay, if I add those together, 4 plus 13 minus 1, that gives me 16 out of 52. Or if we simplify that, 4 out of 13. And that is my probability. Okay, so hopefully this is starting to make a little more sense. We're always adding 2 probabilities together, just sometimes we have to subtract out that extra probability or what they share. Okay, so we're going to skip example 5, example 6, and example 7, and we're going to jump straight to example 8. Okay, so it says there is a spinner with the numbers 1 through 15. If you spin, what is the probability of getting a number that is a multiple of 3 or is a multiple of 2? Okay, so those are my probabilities I'm looking for. All right, well, let's look at this. I'm going to put all my numbers out here, 1, 2, 3, 4, all the way up to 15 here. Okay, now that I've got those listed up, I'm just going to look at one at a time. So it says look for all the multiple of 3s. Okay, well, I can see what's divisible by 3. I know 3 is divisible by 3. I'm going to label my blues A, and I'm going to label my reds B, okay? Well, 3 is divisible by 3. Okay, 6 is also divisible by 3. Another way to think about this is I'm counting by 3s. 3, 6, 9, 12, 15, right? Just counting by 3s. Okay, So I've done all that. Now my multiple of 2's, or count by 2's. 2, 4, 6, 8, 10, 12, and 14 are all multiples of 2. Okay, now I'm just going to set up my probabilities. So the probability of being a multiple of 3, well, I've got 1, 2, 3, 4, 5. 5 numbers that are multiple of 3, right? So I will do 5 out of how many numbers? I've got 15 numbers labeled. Okay. I'm going to add that to the probability of B. How many B's do I have? If I count those up, I get 7 B's out of the 15. And now I have to see, are they mutually exclusive or not? Do they share anything in common? Well, 6 is a multiple of 3 and 2, and 12 is also a multiple of 3 and 2, okay? So I have to come down here and I have to subtract 2 out of my 15, okay? So 5 plus 7 minus 2 gives me 10 out of 15, or if we simplify that, 2 out of 3 as my probability. Okay, now the last one. There are 25 students in class. Of the 25 students, 10 play chess, 16 play magic, and 8 play neither. What is the probability that a student chosen at random plays chess or magic? Okay, so let's look at the probability of playing chess. How many students play chess? 10 of my students play chess. And how many total students do I have? I have 25 students, right? Okay, so 10 out of 25 play chess. I'm going to add that to my next probability. How many students play magic? 16 play magic. Okay, so 16 over 25. Now the question, are these two events mutually exclusive or not? Well, if we remember back to that rule that we were talking about earlier, my total, or 25, should equal all of my other numbers added together. Okay? So 10 plus 16 plus 8 should give me 25. Let's see. So if we put this in our calculator, we get 25 is equal to, it equals 34. 25 is not equal to 34. Okay, and when they don't equal each other, we know it's not mutually exclusive. They share something in common. Well, how much do they share? Well, how many repeats do we have? We can do this by saying 34, or all my numbers added together, subtract my total amount of students, 25. And what does that give us? That gives us 9 students who play chess and play magic. Okay? So we've got 9 overlap here. So I'm going to take that information, I'm going to subtract out my 9 out of 25. Okay? And that's going to give us 10 plus 16 minus 9 gives us 17 out of 25. Okay, and that is it. So don't forget to do the Delta Math online, and thanks for watching.